This is Darren Pulsifer, and welcome to Rise of the Stack Developer, where the convergence of DevOps, security, and cloud-native technologies are changing the way products are developed. On today's episode, we're going to talk about data architectures, where they came from and where they're going. Let's dive right into data architectures, why we need them, and where they're coming from. I can guarantee you that your organization has data. Every organization does. Even a small Etsy business that I run with my wife, we have a lot of data. And what do we do with that data? We do a lot of ad hoc spreadsheets or whatever we can to find out what's going on. And I find in most organizations a lot of odd ad hoc management of data going on. In this episode, we're going to talk about how to move from that ad hocness into different data architectures that are available today, whether it's a data warehouse, a data lake, or these new things called data meshes. So let's dive right into your ad hoc data management. First off, of course, it's going to happen because all of a sudden you've got these smart devices that are generating lots of data, and I don't even know what the data does or what it can do. So there's somewhat of an ad hoc nature to that. And I need to be able to have that ability to do that. But without a data strategy in place, everyone defaults to, well, I need to find out something about customers. Right? Now, with the growth of IoT devices and these smart devices scattered all over, now organizations have even more data. And data they've never thought that they could have before. And they don't know what to do with it. But they do one thing. They keep it all. They don't want to give up any data because they don't know what they don't know. So they're worried that if they throw some old data away, it could have been valuable. That could have given them a leg up on their competition, could have helped discover new product and revenue streams or different ways to monetize things that they never thought of before. A while ago, I was meeting with a pharmaceutical company, and he said, we have so much data. We probably have the cure of cancer somewhere in our data, but we can't get to it. Now think about that. There's so much data out there. So we've got to have a data strategy. We've got to come up with a way of handling this. Ad hoc is not that way. So we've got to look at organizations, what they're doing, start coming up with a strategy with them. Now, one thing that people can do is they can take their ad hoc processes, and I've seen this before, and they replicate them. Now, this may work if your data sets are small, if your organization is small, but as soon as you start getting into the multi-terabyte or petabyte or even exabyte now types of data, you really can't do ad hoc anymore, especially when you now have devices and multiple data centers and devices scattered all over, and some of your data is in the public cloud, some's in your private cloud, some are sitting out on these IoT devices. Ad hoc isn't going to cut it long term, so you got to come up with some strategies. The first strategy that people jump to right away is a data warehouse strategy. So let's talk about data warehouse architectures, right? Very popular. They've been around for about 10, 15 years in that time range. Very well-known problems and very well-known how to address those problems. So it's a great tool to go to if you know what your data is and what you're going to do with it. So it's basically this when you think about a data warehouse. I take data sources. Those could be log files from your systems. They could be sensor data. They could be customer data out of your customer database. They could be order entry. It doesn't matter what kind of data. What you do is you take all of that data and you move it into one warehouse. Now, just moving it there isn't good enough. You actually have to clean that data up, and then you link the data together, and then you make sure that you're normalizing the data so when someone says phone number, it has all of the right bits and bytes that you needed. Or when you say longitude and latitude, you know what that means. right? Now, we also do some transformation of data before we put it into a warehouse. For example, if someone gives a mailing address, it's a great example. I want to probably normalize the mailing address so they're the same for everything. So when I'm running statistics, I'm running analytics, I know that AL is for Alabama and not for something else, right? So that, and it's not spelled out Alabama, that it's just AL for a state, or that the zip codes are either 5 digits or that infamous 9 digits that exist. So I want some consistency in my data. So normalizing the data is extremely important. In order to normalize it, you need to know what you're going to use the data for up front. Now, this is very powerful because it pushes your data scientists to do the work up front, and then you can start pushing large amounts of data through your data warehouse. And then from that, once the data has been normalized, I can create lots of different slices of that data to give me different reports or different views of that data to create valuable information. So I'm actually reusing the same data over for different applications. I'm using that data to get different answers. All right? So this is very, very common, very well known, but I still see organizations not doing this because, it's too hard to clean all the data. Then I don't understand how you would be analyzing the data if it's not somewhat clean, right? Otherwise, you have a lot of garbage coming into your data. Now, some of the downsides of a data warehouse are I've got to move all the data into one place. And when you're talking about large amounts of data, this could be very costly for the transport as well as the storage. Right? Some of these big data warehouses are multi-terabyte databases now with all these linkages, and it can be unwieldy to manage that size. So that's one downside. The other downside is I have to know what I'm going to use the data for up front because I'm manipulating the raw data that's coming in into this normalized form. Now, some people say, well, Darren, you said you need it cleansed and normalized. Yes, you do. But anytime you change raw data, you could be actually losing some data that you didn't know was valid data. So you may lose some of that information that you could use, or that data that you could use later on for different analysis that you hadn't thought of yet. So that's another downside of the data warehouse, right? Some people have overcome that by saying, well, I'm going to have multiple data warehouses and I'll just keep the raw data somewhere. Well, that's an option that a lot of people use, and it sounds a lot like the concept of another architecture, which we'll talk about in a minute. Now, another thing that the data warehouse gives you is it gives you a decreased time to find new answers. If you know what your data cube or your normalized data looks like, now I can slice it different ways, and my data scientist can spend a lot shorter amount of time getting that instead of doing it in an ad hoc process every single time. So that's a major win. Another important thing is it gives me the reusability of that data. It decreased my capital cost overall because I don't have every single department spinning up their own data warehouse or their ad hoc process that they have, which is just chewing up valuable resources, both capital equipment as well as human resources to do that. And it also increases the reliability of the answers that I'm getting because I have cleansed the data up front. Right? So that's a huge benefit of data warehouses. Talked a little bit about data warehouses benefits. Now, the downside, as I mentioned before, is you have to know everything up front before you start, creating your data warehouse. Some things it works pretty well for. Everyone knows an address needs to be normalized. That's a pretty easy one. But there's other data that may not quite be what you expect. Maybe log data coming out of a system or sensor data coming out of something. Some normalization may get rid of events that you may want to look at. In a statistical model, a Poisson event, something outside of the norm, is something I really want to see. So sometimes if you're normalizing data, you may lose some of that. So one of the things we want to do with a data lake architecture is we want to do the cleanse and the normalization according to the applications that are going to use it. So we bind the data to the application as late as we can in the process. But I still want to manage that data. I still want to know what's going on with that data. So a data lake architecture does something a little different. It takes your data sources, it brings the data into the data lake, and then it uses metadata. So it keeps the raw data around, and then it uses metadata to manage the data and to tell it what to do with that data. So the raw data is always going to be there. And then if I cleanse the data, I make a copy of the data that's cleansed, and I create a metadata that shows me my lineage. Where did that data come from? So now that gives me the ability to use the same raw data, managed the same way for different applications. So I always can go back and create new applications on top of that raw data, still under management, still being maintained by my data lake, which can do lots of interesting things with the data, include compression, encryption, tiered storage for decreasing costs. All those sorts of things can happen in a data lake. Now, I've seen a lot of people use data lakes in combination with data warehouses. And this is very common, where they have a data lake that's managing everything, and then they create these data warehouses where I can run multiple applications on top of that as I've grouped them together. So a lot of flexibility with that is available. Now, another thing that you get with a data lake, a downside, is I now have another database called a metadata database, which is storing all this extra data. And in some cases, you'd be surprised, your metadata is actually larger than your raw data, depending on how many different applications you're using and how much compliance requirements and how much metadata you pile on top of that. So you have to keep track of that as well and make sure that you're not having, 5x the storage demand because your metadatabase is so large. So you got to keep that in mind as well, right? Now, the benefits that you get from that late binding of the data to the application are pretty incredible. It allows you to reuse that same raw data without making copies of it for different things, and which could be a new application. It could be a new report that's coming out of that application. I can reuse a group of data for multiple applications, and I can have multiple data sources coming into the same application and being treated differently. I've seen streaming and coming in data lakes, so event-driven applications that are used in data lakes, which gives you a whole new way of thinking about your data. Instead of it being a static entity, now it's dynamic, and I've got streaming coming in. So there's a lot of really cool things you can do with the data lake. The other thing that I get, the other benefit, is the decreased time to applications finding answers, because I'm able to reuse some of the data, that metadata that's already there. I'm able to reuse some of the cleanse that's happened in other applications if they match the same criteria for my new application. So I have a lot of data reuse. I have a lot of, they're called blueprint reuse, how I'm manipulating the data, and a lot of application reuse in this data lake architecture. And because I have the increased reusability of the data, I can also manage the data in this one place as well, where in the data warehouse, I've got data in different places and copies of the data, not nearly as manageable. So it increases my data governance. And when we talk about data governance, we're talking about security, auditability, compliance requirements, classification of data. So all that can be managed under the same umbrella of the data lake. Some of these data lakes can get quite large in the multi-terabyte, and even with some of our larger customers that I've talked to, they're planning for exabyte size data lakes. So a lot of data out there. So a data lake, great idea. There's some downsides to the data lake, and that is the movement of data. Now, this is especially true if you have a lot of remote sites or you have a lot of edge devices. Think of a major retailer that maybe has 3,000 stores across the country. Each one of those stores is generating data. Today, a lot of them move all that data back to a centralized data warehouse, and that can be quite costly for network costs, storage costs, all the things involved in there. Now, imagine just 3,000 stores. That's a big retailer. Now, imagine a automaker, for example, that wants data from their cars. Now, cars generate a lot more data than you would think, a lot more than a retail store would. And I don't have 3,000 cars. I have 100 million cars. Now, what do you do with all that data? So a data lake might not work for that. In fact, it won't work for that. So we have this other concept called a distributed data lake or a data mesh. And this is a new architecture that we're starting to see emerge in the industry. Martin Fowler has produced a paper on that. You'll find a link on our website for Martin's work in the data mesh area. Now, one cool thing about the concept of a data mesh is I don't necessarily have to move my data. In fact, what I'm doing instead is I'm going to move applications and analytics out to where the data is. Because devices are becoming more and more compute capable, more intelligent, I can run applications on those devices. So instead of passing all the raw data back to a data warehouse, I can do some analysis on the edge, creating that metadata layer that now I can now query across 100,000 nodes or a multi-million nodes or only 5 or 6 nodes. But it can all be managed across a federated type of system. So the cool thing about the data mesh, the data lake concept, is a federated metadata layer that gives me the ability to now find out where my data is, and then I can make intelligent decisions on whether I move the data or whether I run small analytics there and move the results to a central place where I need it. A great example of this might be, let's say I've got a camera that is keeping track of inventory in a warehouse. But I have a bunch of union workers working for me, and they're saying, you can't take pictures of us doing work. So I can't stream all that data back into my data warehouse to run things because the union says no. Let's say that's the case. In this case, I can write an application, deploy it out to my cameras, which are smart, that does object detection and is keeping track of my inventory for me. And the only information it's sending back is not raw video data, but object data back. So it's sending me, hey, I found a box of razors. I found a box of toy cars, right? And have that information come back. So that's an example of where a distributed data lake or data mesh could be used, or an application could be written on top of this concept, right? Now, one of the reasons why we're seeing this so much is just because of the sheer volume of data that is being generated, not just on the edge devices, but at these remote data centers. Another great example is in genetic research. This happened to be up in Canada. They do a lot of research in Manitoba with genetic sequencing, and it's petabytes and petabytes of data, and they want to mesh that data with survey data that the Census Bureau has and see if there's any correlation to disease and things like that. Well, moving that kind of data is extremely expensive on those long distances. So with this architecture, I can drop an application onto the distributed data lake. It will know where the data is. It can move the applications out to the data, aggregate the results, and bring them back together. This also gives me an ability to link data across geographical boundaries that I could never do before. that brings up another interesting case around regulation. Many countries and even states in the United States have their own data policies now, where data of the people that live there cannot leave a geographical boundary. Well, this is going to be really difficult if I want to run analytics that say how many people are walking around with a red purse in large cities over 500,000 people, right? I couldn't really do that except moving all the data back to one place. But because of the regulations saying you can't move that data of our citizens outside of our country boundaries, then how am I going to be able to do that except to distribute the analytics out to those places and send the results back? So this architecture lends itself very well to that concept. And the key here is that I only move data based off of policies that I've established, because the policies can include cost, regulations, data gravity, how heavy is the data, how much volume is there, my pipe that I have, my network pipe that I have between locations. All those things come into play, and you want that to happen automatically. You don't want a person sitting there trying to figure that out. It's just too complicated. So these data lake and data mesh architectures lend themselves well to this concept. Like I said, these are brand new concepts. I can't just go buy a data mesh or distributed data lake today, but we're starting to see a lot of tools that can be integrated together to make this happen, right? When I develop an application now, I no longer am tying that application to a physical location anymore. I can now, or even a physical data anymore. I now have a nice abstraction layer. So if I'm writing an application that needs data from a database or a file store or block storage, whatever it is, I can reference it through its metadata layer, which means that the binding of the data to the application is even later than in a normal data lake. It is at runtime. This gives me a lot of flexibility. This means that the application can move and the data can move as well. So this gives me business continuity, disaster recovery, and I'm running the application as close to the data as I possibly can, or I'm moving the data as close to the application as I can. That all depends on the coordination between the data management layer or the information management layer and a service orchestrator. So the benefits that we have with this distributed data lake is you're going to decrease your time to answer. And the way that you do that, you'd say, well, Darren, I got data scattered all over the place. It's going to take time to move it or whatever. You don't have to move all the data. So that's one benefit. The other benefit is your applications don't need to know so much about the physical location of data anymore. So I can write applications a lot faster, a lot simpler, and let the underlying infrastructure handle all the hard stuff, the connectivity of that at runtime, which is helps me get to my answer faster. Now, because of that late binding at runtime, there's so many more benefits. I can inject governance rules in there like compliance, auditability, all classification of data. So this is a really big win-win with this. Now, again, multiple applications can run against the same raw data using the metadata layer, and I can have metadata on a single raw storage. I have different types of metadata for the same raw data, which gives me again more flexibility. Now, this should also decrease your total cost of moving data around. Instead of building these massive, huge data stores to store all your data in your whole company, now your data stores are spread throughout your multiple data centers and even some of your edge devices. In the next episodes coming up, we're going to go into more depth in that distributed data lake architecture. How do we start looking at how it fits into our current infrastructure? We're We're going to start talking also about how to form a data organization with your chief data officer, data stewards, data scientists, all those sorts of things, how they all interact together, changing processes that you need to change to have a more mature organization around data. And we're also going to introduce an information management model, maturity model, so you can find out where you sit compared to your peers. And we can also see where the ultimate nirvana on data architectures will exist in the future. Thanks for listening to Rise of the Stack Developer. If you enjoyed our podcast, go ahead and subscribe, give us 5 stars, and let other people know. If you want more information, like tutorials, videos, white papers, check out our website, riseofthestackdev.com. Until next time, go out and build a new world, one stack at a time.